What's up, team? Today we're going to practice using our triangle similarity criteria. I left this stuff up here from the last video. Congruence criteria, that's a review from a while ago. We're not actually using it today, but I'm leaving it up there because it's familiar to us. Triangle similarity criteria. This is the stuff we're going to be leaning on for today. Okay, so here's what we have. We have these two triangles, ABC and then ECD or EDC. And we know some things. We have a 64-degree angle, a 61-degree angle. This length here is 65 meters. This length here is 85 meters. This is our unknown. We're going to try to find this x. And then we have a 55-degree angle. So, gosh, our task here is to solve for x. We want to find the length of AB. A few things that we need to do here. First, we need to show that these triangles are similar. If they are similar, then we can use some of the ratios and proportions. If they're not similar, then we've just hit a dead end. There's nothing we can do. We don't have the tools to find anything if they're not definitely similar. So our task is to show that they're definitely similar. Let's give it a go. Well, I'm noticing in this triangle over here, EDC, we have two of the angles. We can quickly find the third by subtracting from 180. So if we add these two together, you get 125. So we're just going to do a quick 180 minus 125. And we end up getting, is that 55 degrees? Yeah, I think so. So this is going to be a 55-degree angle. All right, sweet. Let's see if we can make that stuff match the other side. Because remember, we're looking for that angle-angle similarity. Or if we can show side, 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 but we don't have three sides. Or side, angle, side, but we don't have two sides. So we're really going to lean on this angle-angle business. Here we know vertical angles, that's 61. We got a freebie. So far we have two of them. We have 61 and 55. Those match. And 61 plus 55, that's 110, 116. So I'm going to do 180 minus 116. And I think we can see that that's going to end up being 64 degrees, making this 64 degrees. It turns out we didn't actually need to do that. I'm noticing we had two of them that matched already. The 6155, 6155. Well, now we showed they all three match. Cool. So now we can definitely say that triangle ABC is similar to triangle E. Am I doing that right? I don't think so. I think it actually should be DEC. And the reason why I know that is because angle A is 64 degrees, angle D is 64 degrees, so they're the first letters. B is here at 55 degrees, E is 55 degrees, and then C, they both match at 61. Okay, cool. I feel good about this now. So now we definitely have two triangles that are similar to one another. So now we can lean on some of those neat relationships we discussed previously to find our missing piece here. So the way I'm going to set this thing up, I'm going to set it up, I'm going to do AC over DC, which is going to be 85 over 65. Okay, cool. I'm noticing here, I think I have a piece of information missing. I do have a piece of information missing. This is good news. So what we have here is ED is 55 meters. That's given information. I didn't just make that up right now. My phone's ringing, so I'm going to pause this thing. I'll be back. Okay, let's keep pressing on here. So now we can also say that ED, let's change these colors here, ED is EDBA, the same thing as BA. So ED over there is 55, whereas AB is our X. We know that these have the same ratios, so they're proportional to one another. We know that because they're similar figures. If you don't know why, check out 2 videos ago, it's there. So that means we can say that 85 over 65 is the same thing as 55 over X. All right, this is going to get a little bit gross, but here we go. We're going to multiply both sides by X and then multiply both sides by 65. So on the left-hand side, we're going to have 85X. That's what 5s look like, right? And then over here, we're going to have 55 times 65. I don't know what that is, so I'm getting my calculator out. 55 times 65, I just learned, is 3,575. So 85X equals 3,575. Divide both sides by 85. Divide 85. And we learn that X equals 42.06 approximately. I had to get my rounding on. Therefore, our claim is that that's the length of x. It's a little gross. Ooh, yikes, that's different than what I got in my notes. Hang on, let me figure this out. I figured out my mistake. What a great opportunity to learn. I didn't even erase it yet. I'm going to show you my mistake in all of its glory, and I'm going to show you how I would fix it. So when I set up these two ratios over here, I did AC over DC, which is 85 over the 65. That's fine. Notice I did the stuff from the big triangle over the stuff from the small triangle. Okay, and then when I made the second one, I did ED over BA. So I did small triangle over big triangle. Not okay. We have to be consistent. If we did both of them small triangle over big triangle, fine. If we did both of them big triangle over small triangle, fine. When I did it, I screwed up. So this, while this is true, this is not the information that we want. I want to do AB over ED. So I'm flipping it. Again, the reason I'm flipping it is because I want the big triangle stuff over the little triangle stuff. So this is going to be x over 55. Now, I can erase this work. We're really doing the same sort of calculations. We're just going to use the right numbers this time, or the numbers in the right space. So 85 over 65 equals x over 55. Okay, again, cross multiplying. Cross multiplying really is just a game of multiplying both sides by 65 and both sides by 55 at the same time. You're just multiplying by both denominators to get rid of the fractions. 65 times x is 65x. Sweet. Now we're going to do 85 times 55. So I learned 85 times 55. That is even a bigger number, 4675. Great. Divide both sides by 65. Divide by 65. And we learn x equals 71.92. And by equals, it approximately equals this because we had to grab the decimal and round a little bit. So this is how you can use the triangle similarity criteria to solve triangles. First things first, you have to figure out that they're definitely similar. So assume every set of triangles you ever encounter, assume they're always not similar. And you have to convince yourself that they are by using the criteria, either side, 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 angle, side, or just the angle, angle. Once you've established that they are definitely similar, then you can start to use these fun ratios and proportions to solve the missing sides. Be careful not to make the same mistake I did. It's an easy mistake to make. Obviously, I've been doing this for several years, and I still made the mistake. That was not on purpose. So you got to see it, see what these mistakes look like and how easy it can be to make them. Okay, let's dive into some practice problems. Let me know if you have questions. You got this.